Hello everyone, Namaste to all of you. Today we'll be discussing about the further formulas for evaluating the area. In our previous lecture, we studied one important formula to evaluate the area for triangles. That was area A was equal to half of the base times height, which is applicable to all types of triangles, whether the triangle is right angle or acute angle or obtuse angle. And furthermore, we'll be discussing about the types of triangles and their area. Before this lecture, we studied the type of triangles on the basis of their angles. Today we'll be discussing about the type of triangle on the basis of equality of sides, right? Type of triangle. Equilateral triangle. And another is isosceles triangle. And third one is Scalene triangle. In a Scalene triangle, in equilateral triangle, all sides are equals. All sides are equal, and all angles are equal. That is 60 degree. Any two sides are equal. In case of isosceles triangle, two angles opposite to equal sides are equal. All sides have different length. All sides are unequal. That's why all angles are different or unequal. Let this triangle be A, B, C. This triangle be A, B, C, and this triangle A, B, C. In this triangle, all sides are equal. That means AB is equal to BC is equal to CA. All angles are equal, and each angle is 60 degree. This angle is 60 degree. This angle 60. This angle is 60. Angle A is equal to angle B is equal to angle C, and they all are equal to 60 degree. And in this triangle, isosceles triangle, two sides are equal, right? AC and CB, these two sides are equal. Here AC is equal to BC, which is not equal to AB. And the angle opposite to AC is angle B, and the angle opposite to BC is angle A. So angle A is equal to angle B. And in case of scalene triangle, all sides are different. They are not equal to each other. Angle A, all sides are different. That means AB not equal to BC not equal to CA or AC. And angle A is not equal to angle B is not equal to angle C. Now we derive the formula to find the area and perimeter of each type of triangle. Consider equilateral triangle. All sides are equal. Let the length of all sides is A. If we know the length of a side in an equilateral triangle ABC as a unit, then find its area. This is our main goal, and we do not know how to find the area of this triangle, but we know if we have been given base and height, then we can easily find the area of any type of triangles. We have the formula half of base times height. So let us do some manipulation in this triangle. This is a triangle. A, B, C. Each side is equal to A. Let us draw perpendicular from this vertex. Perpendicular at point D on side AB. And in case of right triangle, we have to remember one result, that is perpendicular drawn from any one vertex to opposite side in an equilateral triangle bisects that side. It means from vertex C, a perpendicular has been drawn on the opposite side, that is AB. and if this is perpendicular, then it will bisect this AB segment in equal parts. That means AD is equal to DB. Here the total length of AB is A. This is A, and it is bisected. A is bisected at point D. That means AD has a length half and DB has a length half. This length will be and we see there are two right angle triangles, triangle 1 and triangle 2. We know the formula to find the area of right angle triangle. So the area of this this equilateral triangle ABC is equal to the sum of the area of these two right angle triangles. That's why we have to find the area of this right angle triangle, we have to evaluate the height, that is CD. CD is the height for each right angle triangle 1 and 2. So finding height, let us say as that is equal to CD. It is to be evaluated in right angle triangle ADC. Hypotenuse that is, let us consider hypotenuse is AC, that is equal to A unit, and base is AD, that is equal to 1 by 2. We have to find perpendicular, which will be height for right angle triangle, right? Perpendicular, that is CD, is to be calculated, and by using Pythagoras theorem, using Pythagoras theorem, perpendicular CD would be equal to hypotenuse squared minus base squared. Hypotenuse is AC squared minus base squared, that is AD squared, right? And AC is A squared and AD is half of A squared. This will be A square minus this will be A square upon 4. We are taking LCM. LCM is 4 and multiplied by 4. AC square is multiplied by 4 and minus, and A square is as it is, right? If you do not understand this, look at this example 1 by 2. How to evaluate this? This is if there is nothing, then the denominator of 2 will be 1. The LCM of 1 and 2 is 2, right? And 2 is multiplied by 2 because here 1 is first we have to divide this LCM by 1. We will get 2. That will multiplied be multiplied with numerator 2, and here minus 1 will be multiplied with the result when we divide when you divide 2, this is LCM by 2, we'll get 1. This 1 will multiplied by 1, no matter that will give us 2 to the 4 and 1, that is 3 by 2, right? Similarly, if I have A and 1 by A, how to evaluate it? First of all, multiplied 1 and A, just multiplied it. To find the LCM, LCM is A, and A is multiplied. What is absent in the denominator of A? There is 1 and A is absent, that's why A multiplied by A and 1, and look at the denominator of 1, A, and look at the LCM, and what is absent from the denominator of 1? Nothing. Here A, nothing, that means 1, right? So A square minus 1 divided by A. We evaluate in this way. And similarly, in case of numerator, here for A square minus A square, we will obtain 3A square divided by 4, and under root is distributed to numerator and denominator. Under root 3 cannot come out of the under root, square root, and A will come out because A is A squared, and 4 will come out as 2 because on square root of 4 is 2, right? And we know the height and base, so area of equilateral triangle will be triangle ABC. A will be area of right angle triangle. There are two right angle triangle. They are ADC and BDC. Right angle triangle ADC plus area of right angle triangle BDC, right? For right angle triangle ADC, this area is equal to half of base. What is base? Here base for right angle triangle 1, base is AD, height is DC. Base is AD, height is DC. Similarly, for right angle triangle BDC, base is BG and height is DC. Look at this triangle. For right angle triangle, for second right angle triangle, BD is base and DC is height. We know the value of its base and height. AD is equal to half, and DC is height. DC is height or CD. Here I have written CD, which is same as DC. This is height. This is a height, which is equal to height. This is height plus 1 by BD. BD is equal to half of A, and DC is S, right? And we have calculated the expression of S in terms of A into A by 2. S is equal to under 3 under root 3A upon 2 plus 1 by 2 A upon 2 to under root 3 A upon 2. Multiply numerator and denominator separately. 1 into A into under root 3, that is equal to under root 3 A square, and 2 to the 4, 4 to the 8. Similarly, under root 3 A square 8, and both are equal. That is, here this is one expression, this is the same expression. That is 2 times of same expression. That is, if we further simplify, 2 it's cancelled, and here in denominator we'll have 4. This is the area which will be in square units, right? Square units. Hence area of equilateral triangle. Equilateral triangle will be equal to this expression. That means if we know the side of an equilateral triangle, we can easily evaluate the area of that triangle by using this formula, under root 3a squared upon 4. Similarly, what about the isosceles triangles? Well, let us now discuss about isosceles triangles. Isosceles triangle. Let's consider A, B, C is an isosceles triangle with two sides. Let this side A and this side is also A. Whose two sides are equal and third side is different from these two sides. The unequal side may be B, right? Similarly, the same result is applied here. We do not know the height of this triangle. First of all, we have to draw the perpendicular from C to AB. And in case of isosceles triangle as well, the perpendicular will bisect the side AB in two equal parts. That is, if I draw perpendicular, let us say this is a perpendicular drawn from vertex C at point D, and AB has a length B. And this triangle, this is a height. This is a height. Let us say height is S, and for this triangle, it is divided into two triangles, two right angle triangles, 1 and 2. These two are right angle triangle. This is D, right? ADC and BDC are two right angle triangles. The area of these two right angles, when we add, it will provide the area of the whole isosceles triangles. Okay, first of all, how to find the height? If we have been given side length only A and B, how to evaluate the area of these triangles? If we draw perpendicular from C to this opposite side AB, this perpendicular line will bisect this base, and this will be equal to B by 2, and this will be B by 2. This length will be B by 2, and this will be B by 2. And in these two right angle triangles, we have base, that is B by 2, and now we have to calculate the height. First of all, being right angle triangle, we can use the Pythagoras theorem. So by using the Pythagoras theorems here, so in right triangle ADC, using Pythagoras theorem, the perpendicular, that is DC, will be equal to hypotenuse squared minus, first of all, I'll write it perpendicular, right? perpendicular minus base square. In first right angle triangle, hypotenuse is AC, AC squared minus base is AD, AD squared. That means AC is A squared, AD is B by 2 squared. That is equal to A square minus B square upon 4. Taking LCM, that is 4A square minus B square whole upon 4. Distributing this radical sign or under root, square root to both numerator and denominator. Numerator cannot come out of this radical sign or square root, which will be written as it is, and 4 will come out as 2, right? This is unit. This is a height. This is the expression for height. And now area of isosceles triangle ABC. A will be equal to sum of area of right triangles, right triangles, right triangles ADC and DBC. ADC, right angle triangles ADC and BDC. Here in these two right angle triangles, this is A and this is A, and base are also equal. This is AD is equal to BD, and height is same for both the right angle triangles. It means they are equal to each other, right? They are equal in area. They are identical. That's why we can write 2 times of area of one right angle triangle, because they are equal. So area of one right angle triangle plus area of second right angle triangle is 2 times of area of one right angle triangle, because both are same. That's why 2 times of area of right angle triangle. Let us consider first right angle triangle, that is triangle ADC, right? This will be 2 times. In case of any triangle, when we know the base and height of that triangle, so we can easily evaluate the area of that triangle, that is half into base into height, right? Height for ADC. Here half base is for ADC. In this triangle ADC, base is AD and height is DC. Base is AD, height is DC. You can cancel 2 and it will give us 1, and when 1 is multiplied with some quantity, and that quantity will be remain same, that is AD. AD is B by 2 from above triangle. AD is B by 2 and DC is height. DC is height, that is equal to under root 4A square minus B square by 2. Here DC is height, height S, and which has been obtained as 4A square minus B square by 2, and AD is AD is base, which is equal to B by 2, right? So no, multiply numerator with numerator and denominator with denominator. B times this expression is equal to this, and 2 to the 4. We in algebra we know x times y can be written as xy or x dot y. So here b times under root 4a square minus b square can be written as b under root 4a square minus b. Both are same, right? In algebra, we treat dot as a product, as a multiplication. So these are the basics uh, of algebra you have to keep in mind. So area of isosceles triangle A is equal to b a square minus b square by 4, where a is length of equal side, and it is length of equal side, one of the equal sides, and b is length of remaining side or length of unequal side. So we evaluate the formula for isosceles triangle as well as equilateral triangles, and the remaining is scalene triangle. In case of scalene triangles, we have another formula that is known as a Heron's formula, or if we know the base and height of scalene triangles, we can easily find, because we know the formula in any type of triangle. So the area is equal to half of base into height. But if we know the three side of an scalene triangle, in that case we use Heron's formula. That will be discussed in class 9, and we will not discuss um, that here in class 8, and we leave it for your next class. We'll only study isosceles triangles and equilateral triangles. Now let us write all the formulas for triangles. Triangles, area, perimeter P. We study right angle triangle, right? A, B, C. If we know base, perpendicular, P, and hypotenuse, then area is equal to half of base into height, or BP, and perimeter will be P would be equal to this. And the second, acute angle triangle. ABC is an acute angle triangle. In this case, we have been given the height. This is height as, and we have been given base, length of base. Now we know base B. In this case, area is equal to half base into height, and perimeter in this case, if we know the base and height, we cannot write the perimeter, we cannot evaluate the perimeter in this case, because to evaluate the perimeter we should have the length of another two sides, AC and CB, which have not been given here. That's why it has been left as it is. And in case of obtuse triangle, we know the height. This is a perpendicular. This is a perpendicular. When D, perpendicular at D, this is a height and this is a base. In this case, area is equal to half times B into H. And other two sides are unknown. That's why here perimeter cannot be determined. Similarly, equilateral triangle. Equilateral triangle ABC, all sides are equal and length is A. In this case, area is under root 3 A squared by 4. And perimeter is, in this case, we can write perimeter is equal to sum of all sides, that is 3A. Similarly, for isosceles triangle, A, B, C, whose two sides are equal. Let us say equal side has a length A and unequal side has length B. In this case, area is area A is equal to B times 4A square minus B square by 4. And perimeter is B is equal to sum of all sides 2A plus B. These are the all formulas related to area of different types of triangles. If we have been given right angle triangle, we use this formula. If we have been given acute angle triangle and we know the base and height, in this case we use this formula, base into height formula. And if we know the base and height of this angle triangle, we use the same formula. This formula is valid for all types of triangles. We have proved this statement in our previous lecture. And when we have been given isosceles triangles and equilateral triangles, in this case, for equilateral triangles, we use this formula under root 3 A square by 4. And in case of isosceles triangle, we use the formula unequal side times under root of 4 A square minus B square whole upon 4. These are the formulas related to areas of different types of triangles.